Welcome everyone to our webinar. We're going to be talking about what else? GenAI, but we're going to talk about it in the context of the RAN, the Radio Access Network. And joining me today is Ravi from Aira. I'll let him introduce himself shortly. And they have a pretty cool demo, one that I've seen recently, and I would say that it's one of the top demos I've seen in GenAI in the telco world. I think you're in for a treat. So let me turn it over to Ravi to introduce himself and Aira. Ravi?
Hey folks, I'm Ravi. I'm a co-founder and CTO for Aira Technologies. I am responsible for the tech stack at the company. By way of introduction, I have a few decades of experience in wireless communications and telco. Did my bachelor's through PhD in this space. Spent a couple of decades in the industry, most notably at Bell Labs and Qualcomm, and started Aira Technologies with the vision of exploring the intersection of data-driven, machine learning powered approach to solving problems in wireless communication. And over the last few years, we have squarely been focusing this on telcos and the RAN stack. Nice to have this conversation with you, Roy.
Excellent. You have one of the more compelling Gen AI demos that's not BS out there for sure. This is actually quite compelling. So talk to us about RANGPT and the idea behind it. What does it solve? What are the challenges that RANGPT is supposed to solve?
Yeah, so the way and I'll get into who we are in a second, but I'll answer the question first, which is the way we thought about RAN-GPT was almost with a doctor-patient approach. Like if you're a patient going to a doctor, asks you a series of questions around, hey, how's your health, what's been bothering you, and a patient kind of answers, and doctor is the expert, but the patient is the one who has all the data and information. So similarly, if you think of an expert that's trying to understand what's going on with the network, or try to debug something, or try to create a manage an incident, it's the network that has all the information. The data is all present in the network. The expert knows how to debug and knows to root cause and figure out a solution. But this process of querying, in the former case, a doctor patient case, happens very naturally using natural language. But in the RAN world, it's very involved. There's big data involved. There's multiple teams involved. It takes potentially multiple days or even weeks before a new visualization or a new answer can be provided for the expert, because now the expert is the one who knows what's the question to ask, but then that question needs to be translated into big data code, and that expertise potentially is in some other team. So you can imagine this taking a while. And we thought of RANGPT. The first use case that came to mind was, why don't we make that process as natural as a doctor-patient conversation? Why can't the RAN expert have a conversation with the network, ask questions that the network is able to answer, and won't that speed up the entire process? And that's what we've been able to achieve. But then we've also added a few other use cases, like the ability to control the network and the ability to write small automations on the network, and we'll go through those today.
Excellent. That's interesting. Looking forward to it. So why don't you go ahead and maybe give us the background on Aira?
Aira is a company which was formed in 2020, like I mentioned, to explore the intersection of data-driven approach to wireless. It's the co-founding team is a seasoned team. If I say so myself, I'm one of the co-founders. I have introduced myself already. The CEO is Anand Chandrasekhar, who's been in the space, the high-tech space, for at least 3 to 4 decades. It has held leadership positions both at Intel and Qualcomm, and has managed big teams both in the processing space as well as in the semiconductor space. There are two other academic co-founders in the company, Pramod and Sriram. Both of them had been exploring the intersection of machine learning and wireless from an academic standpoint when we approached them, and we joined forces and started Aira together in 2020. Beyond the four co-founders, the leadership team is completed with Babak, who comes to us from a lot of experience with telco vendors, most notably Ericsson, Navineer, Parallel, and so on. and he brings a wealth of telco experience and expertise into the team. And Sanjeev, who helps us out as a product architect, has spent multiple decades both at Bell Labs as well as Qualcomm, and has led multiple research initiatives and activities within those companies. So he helps us out with thinking about the problem and coming up with efficient product architectures. And finally, Alex is our BD and salesperson who heads out a lot of our outgoing outreach. So that's Aira, who we are as a company.
Mm.
What we do, our niche is in being able to generate insights from data. This is what I call Aira on one slide. This is who we are. This is what we do. We can ingest data from lower layers, physical layer 1, layer 2 via E2 interface, and generate insights around delay spreads and Dopplers and network conditions. Those insights can be used to do channel prediction and beam management and more accurate direction of energy to the users. And similarly, we can also ingest data from the higher layers, configuration data, performance metrics via O1R1, and generate insights around mobility classes of the users, how many users are mobile versus static, how many users are indoor versus outdoor. These insights can be used to better manage the network in terms of an energy efficiency perspective, which cells to put into a lock condition, and we showcase that as an R app. So we have two apps today which uses these insights. The X app, which can do beam management and improve multi-user MIMO throughput and spectral efficiency by about a factor of 2.4, and the energy efficiency R app, which can improve energy efficiency of the network by about 25%. So these are two apps that we showcased in MWC 23. The third capability that we've been developing this year is RANGPT, which is a conversational interface to both the apps that we have, but also more importantly to the raw data as well as the insights that the network is generating. So that's who we are, that's what we are developing. And in terms of our go to market, our initial go to market is basically apps. There's so much opportunity with the introduction of an NSMO and the RICs, both near real time and non real time. I think we'll be busy building apps for the near future. Eventually, we do want to go into building the DU and further vertically expand, but for the near future, we're going to be busy building apps. So that's
Yeah, I
who we
think
are as IRA.
that's the premise, I think, of the Open RAN ecosystem, to provide opportunities for companies like Aira to be focused on developing things like XApp and RApps, at least, for the time being, but fit into a larger ecosystem where you have the leverage of taking your IP and then applying it to a full RAN. You don't have to build a whole RAN. You can play part of the RAN ecosystem, add value where you have deep expertise. You're a classic
Exactly.
example of that, right? So perfect. Excellent. So let's talk about your RAN GPT and maybe talk about some of the concepts that make up your RAN GPT. Not all the attendees are probably going to be super familiar. They know roughly what GenAI is. They probably have played with ChatGPT, but this is not ChatGPT. This is RAN GPT. So go ahead and let's talk about the components and the
Yes.
elements. Yeah, yeah,
Yeah. Yeah, we'll be doing a demo today and we'll talk about RANGPT and the different components. And like I mentioned, we think about RANGPT as a way to interact with the network. And I'll be showcasing a few different personalities of this querying capability and what we want, but some caveats, some level setting. This is not currently a product. All the people this particular video is going to go out to, we have demonstrated this potentially in one form or the other, and we've been soliciting feedback. This is right now, in our opinion, a capability that we have developed. How do you map it to a product? What's the most impactful user case? Who's the right persona? All that is what we are trying to do by doing this outreach. And so with that in mind, this is a raw demonstration of our capability. Don't expect bells and whistles that will come when it gets mapped to a real product. Same issues with stability, and the demo might break. So all of that, bear with it as we do the demo. And what we're really trying to get out of it is, like I mentioned, showcase the capability, understand what the use cases might be from the market, and find the right user persona, and also honestly find early adopters who are willing to co-develop and who are willing to find out, go join the journey with us in defining an impactful product and an impactful persona and a use case with us. So that's also, we've been fortunate to find a few of those already, but we are always looking for more. So that's also one of the goals out of this webinar and the presentation here. Getting to the question you asked, Roy, what you'll be seeing in the demo really is a person or a user interacting with a UI,
Mm-hmm.
but behind the scenes, and the UI will be giving, sometimes spitting out code, sometimes it'll spit out nice looking plots, but behind the scenes, there's multiple modules that are in action. This is most certainly not just OpenAI or not just a foundational model. Foundational model is just one component. So behind the scenes, there's a foundational model. This demo, we are using OpenAI. There's work underway to have alternatives to OpenAI like Llama 2 and other potentially foundational models that can be placed in house. That's the foundational model aspect of it. Then there is data. At the end of the day, the code that we generate needs to run on some data lake. We have access to some operator data that we have thoroughly anonymized, and that's what we are going to be showcasing the demo on, some real operator data. And then there are
Mm-hmm.
two other components that we had to develop. One is a telco translator, which is essentially an unstructured vector database with information about the definitions of different columns that are present in the data lake, but also a lot of unstructured information around how a particular operator defines certain parameters like energy consumption and efficiency. There could be nuances to how this is defined on a per operator basis. There's also standard rules and guardrails that operators might have, that all of those kind of go into the telco translator. And then the most important component is the orchestrator, which is again an Aira module, which decides when to call the foundational model, when to get definitions, when to get code and run it, and when to go back to the foundational model. So sometimes a lot of what you're seeing, there is multiple turns around these carousel that the orchestrator is able to do for us. So that's going to be the demo.
Excellent. I think in terms of some of these elements here that you talk about components, there's obviously the data element, right? What do you say when the telco says, oh, that data is super sensitive? Now, obviously in the demo you're masking it, but in the real world, on an ongoing basis, there still needs to be data protection.
Yeah.
What's your view on that? Yeah.
Yeah, there are great question. There's two approaches or two components to that solution. One, the ultimate answer is have an in-house foundational model, so your entire operation stays in-house and the data never leaves your walled garden.
Hmm.
That's probably what most operators want to hear. But there are challenges with, then you are stuck with maintaining that foundational model, and you are stuck with
Hmm.
kind of making sure that it's being tracked and all that, and you are stuck running it, and you may not have some of the scaling advantages that others might get by running this at scale. So we also believe that there is a solution where the foundational model itself might still be open, but the kind of information that you feed the foundational model is heavily anonymized, or for example in the demo that we are about to show you, no actual data actually hits the foundational model. It's only the schema of the database that hits the foundational model, and then foundational model generates code that can effectively operate on the schema, and the code is run locally on real data. So that's another
Mm,
way of solving for
mm,
this problem.
mm.
We don't know which one is going to be the dominant mode at this point, most likely the
Right,
former,
right.
but there are other modes available as well.
Yeah, no, I think you guys are pretty smart in terms of building that flexibility as models change, as the workflow change, you need that level of flexibility, right? And I think that also helps
Yeah.
you with that flexibility, also allows you to run the FM maybe on-prem, right? Not everything, as you said, not everything be in the cloud. It can be the code can be run on-prem. You talked about the telco translator. I think you
Yes.
explained a little bit about what the telco translator does is how do you come up with that concept as part of the workflow? Because other people are saying we maybe just put it in the context window or throw it in there or magically it'll figure it out, which it doesn't. But how did the idea come
Yeah.
about, the telco translator? Yeah.
Yeah, if you're following the LLM space, retrieval augmented generation, the RAG as they call it, is a pretty well known concept now. Telco translator is part of our RAG. It's not the only
Hmm.
component. There is a specific template with which we query the foundational model, which is very unique to us. It involves the original question and various other components which I cannot get into, but components that come out of this translator is definitely one component that goes into the ultimate query that hits the foundational model.
Mm.
And
Mm.
yeah, there's just so much data that you can imagine there's probably thousands of KPIs that a
Hmm.
network has, and each KPI has a very specific definition. Each
Hmm.
column within your data lake has a very specific definition. You cannot just throw all of that into your query. A, the foundational model will get confused. B, it may not have the capacity to intake all of that. So we believe in RAG, and telco translator does help us provide that RAG capability to identify the narrow context which is relevant to the question that's being asked, and then
Hmm.
augment your query with that narrow context.
Thank you. No, that was helpful. Really appreciate it. And I think for the audience members who are not familiar with RAG or retrieval augmented generation, you can go take a look at it. And a lot of it has to do with the fact that you may have a lot of data that you want to use as part of your GenAI workflow, and you can't fit the whole thing into what is known as a context window. Most of the foundation models have different context window sizes, and most of them are less than 32K. In fact, most of them are less than 8K or even 4K that you have to deal with. Now, and obviously, they'll get bigger over time, but retrieval augmentation is a way where you can help overcome some of that window, but also add more grounding to some of the output in terms of the process. So I suggest you take a look at that. All right, now it's demo time, which is always exciting. So I think we're going to see 3 demos today. Is that right, Ravi? 3 demos. Can you maybe talk about the 3 at high level and then jump right in? Yeah.
Absolutely. Yeah, there are three what we call personalities that we'll be showcasing of the RANGPT. One is the querying personality. How do you use a conversational interface to just query the network, ask questions,
Hmm.
and get answers? Then there is the control personality, which is conversationally asking network to do certain things. For example, should shut down certain bands. And then there is a third component which is going towards zero touch provisioning, where you can daisy chain these two personalities and say, when a certain event happens, which is a query, then do
Hmm.
certain action. Now if you put these two
Mm.
together, you can create mini routines that can almost like a RAP generator, if you will. Simple RAPs can be generated out of
Mm.
this, and you can use your standard SMO functionality to then lifecycle manage those RAPs. So those are the three things we'll try to showcase,
Interesting.
and we can jump in.
Go ahead. Yeah. Yeah. Go right ahead. Let's do demo one.
Yeah. So this is the UI that I was talking about. This is, think of it as what a user is presented. Once again, I made this point before. This is not the final product, it's a capability demonstration. So eventually there'll be probably more bells and whistles on the screen, but right now this is a query.
Hmm.
And remember, this UI is connected to operator data in the backend, anonymized operator data in the backend. So now let's
Right.
ask
Right.
questions like, for example, how many use, no, something like plot the number use. So what I'm asking here is, hey, every site has a bunch of users connected to it right now.
Hmm.
Just give me a sense for which site has how much traffic. And it's not necessarily the most well-defined of questions, but that's the nice thing about RANGPT, is that it understands the user's intent and it acts on the intent rather than the very specific definition. Long story short, you can see that it gave out a nice plot of
Mm-hmm.
users connected to each site. There's 6 sites in this example in the demo that we had, and different sites have different number of users. But more
Mm-hmm.
importantly, we have asked the foundational model and the entire RANGPT to not just give us the answers, but go through the thought process so that we can understand what it's doing. And we find that to be very useful because it's, once again, it's an iterative querying that ultimately works. So understanding its thought process helps us ask better questions the next time, and so on. So here it's saying I need to plot the number of users, and I can get that from this very specific column name called RRC connection mean. How does it know that? That's where the telco translator is kicking in. It's giving the translation between number of users connected to a site and a very specific column name in the data. And then it wrote code that is then run on the data lake, and that's how we get this plot at the end. I can
Nice.
imagine,
Nice.
especially if this is big data and you have to write PySpark or Hadoop kind of code, I can imagine this taking. This is a simple question, but it's not necessarily very simple code to write for a domain expert. A RAN expert may
Mm-hmm.
not be
Mm-hmm.
an expert in Hadoop code or PySpark code. So that's where we really believe there's a big advantage for a tool like this. But let's go beyond.
Yep. Yeah. Now
Let's
let's
ask
go
it. It's a
next step. Yeah.
conversational interface. So it's a conversational interface. So let's see how we can build on that query. So let's say I want to say, for example, on the same plot, separate the users connected to each band, stack bands into the same column. So what I'm trying to say is every site has multiple bands. There are capacity
Mm-hmm.
bands and coverage bands. I know in this example, there's 4 capacity bands and a coverage band. I want to know more.
Mm-hmm.
You have given me
Mm.
how many users are connected to every site. I want to now break it down into a per band connectivity. And again, not necessarily the most well formed of questions, but it gets the idea, and it gives you what you've asked. So let's see what it does. The thought came out first: I need to separate the number of users on a per band basis, then I'll create a stack
Mm-hmm.
bar plot, everything that I asked. So it's able to parse that out, and it's going to write code,
Mm-hmm.
and that code is now being run, and there it is. You have a
Mm-hmm.
plot, not just with number of users, but split into each band. On the same plot, overlay the average energy efficiency of the site. I'm saying that's great, but on the same plot, won't it be nice to see how the number of users and the different bands correspond to the eventual energy efficiency of the site itself? And this is a very complex ask. We are saying, remember the previous context, remember the previous plot and the
Mm-hmm.
numbers and all that, and the way the code was written. But now go calculate a completely new thing, which is in itself a very complicated thing. How do you define energy efficiency? It's not directly present as a column in the data.
Mm-hmm.
You need to
Mm-hmm.
take total throughput, total number of users, you need to divide them and come up with an energy efficiency on a per site basis, and then overlay all of that in the previous code.
Mm.
So it's a complex ask, and even just
Yes.
visualizing this in the same plot is a complex ask. And let's see if it gave the right thought. It wrote code which didn't break, and now it's running that code on the data. And let's see how the plot looks. You can see that this is the time it takes is for it to go do this multiple loops of iteration through our orchestrator and running code, and then going back to the orchestrator and so on. And there it is. You have your original plot with the number of users connected to each site, and on a per site basis it's also plotting energy efficiency, where energy efficiency is on this axis, number of users is on this axis. And it's a good visualization potentially to use. And What we have also done here is, you can imagine at the end of the day, it's this code running on the data
Yeah.
lake that's
Right.
generating this graph. But to get to this code, you had to go through multiple iterations of hitting the foundational model and so on. But you can totally imagine, once you like a visualization, you can cut that process out and just run this code on the data lake at whatever frequency you want, and you'll keep regenerating this code. So we had a shortcut to do that called create a listener, where if you hit this, it will create a dashboard, almost like an instant dashboard that you can maintain, of various visualizations that you like, almost like a personalized dashboard that you want as a debugger perhaps. So this is standard software engineering at play, taking the code, running it on the data lake at a particular frequency. I won't go into
Hmm.
that, but that's the
Hmm.
first persona, the first personality,
Interesting. Yeah.
which is the ability to query the network and get interesting
Hmm.
visualizations and information out of it.
Yeah, no, I think that's really interesting because, as you said, a lot of time you have to use an analytics team or someone who actually goes in deep. Plus, you have to know the calculation dictionaries to translate. When I say how efficient, what does that mean? And I think the ability of it to generate the code to actually drill down into some of the data is really good because after you like the view, you can reuse the code again and run it against the data. Very good. That was demo one. Let's go to demo two. RankGPT in control.
Yeah.
So yeah.
Demo 2 or personality 2 is, how do you, now that you know how to query, you can imagine setting certain alerts and saying,
Yeah.
if the energy efficiency of a particular thing is below some number, do something, right? So there,
Hmm.
that's eventually the third one. But how do you directly control it? Let's say shut down capacity band of the site with the least energy efficiency. So let's ask this question, where we are asking it to shut down the site with the least energy
Hmm.
efficiency. That's
Hmm.
giving it a thought. Now it's in the process of trying to generate code. Okay, there it is. It came out with the observation on a per site per band basis. It's computing energy efficiency, and then now it needs to find the sites with least energy efficiency and shut it down. So it's gonna do that. It's writing code for that. Okay, and in that process, it made a mistake, and it's trying to correct that mistake. Ah, there it goes. Now
Mm.
it did not, it fixed itself, fixed its error. It came out with the observation that site 1 and site 1 and these are the three bands that it found are the ones with the least energy efficiency. So it's going to say site 1 and these capacity bands have been shut down. And
Mm.
so you can imagine this, there's a natural question: how does it interact with the elements of the RAN stack, and how does it know
Hmm.
how to send that command to the DU for the DU to shut it down? That's where the SMO comes in.
Mm.
All
Mm.
we
Mm.
need to give the SMO is what is the site ID and what's the band ID, and there are standard interfaces via R1 and O1. Now this needs to be mapped into those interfaces, but that's again standard software. You can imagine writing a template where it can map the site ID, band ID to a R101 command that then the elements and the DU can obey in a ORAN ecosystem. If you are in a SON kind of a system, there would be equivalent commands you can map it to. It's just simply a question of writing the right adapter. But the capability is there. You can conversationally ask certain complex things of RANGPT, and it will do the calculation and it will identify the right sites and bands for you to go and uh, take actions on.
Excellent. Very good. No, very impressive demo. That's pretty nice. And then obviously now you can take action. You can run queries. The next step is,
Yeah.
autonomous. Obviously we're not there, but let's take a quick, or maybe we are there. Let's take a look at the demo. Yeah.
Yeah, the third component is putting these two together. Is probably the least developed aspect of RAN GPT, because it honestly is very operator dependent. What kind of routines do you want to run? And it's very user defined. So we have proactively gone ahead and defined certain routines. Like, for example, we can say things like optimize for energy efficiency. So Aira as a company comes from energy efficiency space. We have written an R app. So a lot of the examples we use come from that space. But you can imagine writing a routine for restarting sites that are dormant or restarting sites that are stuck in a bad condition. So the idea is for user defined functionality to be defined with a very specific or very simple language that you can conversationally kick off. But then behind the scenes there is a series of steps that you can define. For in this case, we are saying don't shut down the least energy efficient site, but shut down the sites which have energy efficiency that's 50% lower than the mean energy efficiency of the entire system or the entire network. So that's the rule, or that's the way we have defined this routine, and it's going to go behind the scenes and execute on that. And in that process, it will make mistakes and it'll correct itself and so on. But the idea is for operators to giving operators the capability of defining their own mini routines or mini subroutines that they can just very easily kick off or even automate. That's the third capability that we think will be interesting.
Yep. So certainly, I think to the extent that it can do the reasoning, it can check its own output, it can determine what it's trying to get to, and then get there. And I think I think a couple of things. One is the foundation models get better as you guys figure out how to tune it, augment it, do all the whatever it is that's necessary. Then certainly the cycle time can be reduced, and then you get to an autonomous agent mode for RANGPT, right? That's the dream, right? Then it can work things out for you. You can say, give me, yeah, I don't know. Ideally, at the high level, just lower the temperature of the planet by 1%. Then it calculates, oh, look, this particular RAN operator has that X amount of things. If I take this down, I'll meet the goals, all that. But very impressive and obviously a very valid use case, a very
Thank you.
interesting use of it. Yeah, very good. One of the things is where do you expect to see the agent running? What kind of guardrails? Obviously, it's checking its output. It's not going out there and just taking control and doing what it wants to do right away. How do you see that progressing? What do you have in place today?
Yeah. So one thing is, unlike probably ChatGPT, where it's mostly conversational and you can ask it questions and it can give you very inappropriate answers and so on. Here, RANGPT, the output is always code. Especially in most of the demos that I just showed, the output is code, and the code is what is being run on the data lake. So you can imagine putting standard code based guardrails, like there are certain variables that you shall not modify, any code shall not modify, or certain actions that this code is forbidden to take. So this standard software practices, right? The
Right,
just the
right, right.
hygiene that software as an industry has been developing over the last, all of that can be leveraged. That's how we ourselves use certain guardrails. But there are also
Yep.
conversational foundational model guardrails that telco translator can ingest. So we, for example, have specifically mentioned that the capacity band shall never be shut down. And that's a conversational rule that we can embed into the telco translator. It doesn't need to be mapped into what is a coverage band and what are the band IDs on a per site basis. You can just encapsulate that rule by saying just don't shut down coverage band, right?
Right,
and
right.
and the foundational model will respect that. So that's another way
Yep.
of putting guardrails.
Got it. Got it. Excellent. Excellent. Now, as we talked the first time I saw the demo, that's pretty cool. It's a really good use case of Gen AI. And as you point out, it's not about chatting with, it's actually generating code that actually does something with visualization that allows you to query, ask questions without, like when you did data analytics normally, right? There's a lot of prep work that you have to do in terms of the querying and sophistication and the variables and the parameters. And with this, it was pretty nice, pretty straightforward. You ask a question that seems perfectly reasonable, and you get back visualizations that you can actually save and reuse again. Very useful, and even drill downs and interact with that.
Yeah.
What's been the feedback as you've shown this to the MNOs and the operators out there? What's the feedback so far? Do they like it? What are they saying?
Overall, feedback has been very positive.
Mm-hmm.
Obviously, every operator is looking or is interested and very curious about applications of this technology to their space, which in itself I find very refreshing that everybody is so
Mm-hmm.
open to adopting this. Uh, and coming to specifics of the feedback, it's a big spectrum, as you can imagine. We've had more conservative feedback around the lines of, hey, we need to identify a very specific, very narrow use case that's highly impactful, that's being demanded by the operational team. And then
Mm-hmm.
let's see how that can be solved by a conversational interface, or maybe doesn't even need a conversational interface. So there is that
Yeah.
one end of it, and the other
Mm-hmm.
end of it, where we sometimes defined this capability as a co-pilot, where the operators have been, no, let's go beyond copilot. I want autopilot. I want this to
Yeah.
run on its own and fix
Mm-hmm.
networks and heal itself. And so there's a big spectrum, but overall, one of the personalities that has come out that's interesting is this incident management expert,
Yeah.
co-pilot expert assistants, to go find out what's going on with the network, understand what's going on with the network, with the eye of
Mm.
potentially either fixing incidents that are happening in the network, or maybe better understanding the network with the eye towards better designing
Mm.
the
Mm. Mm.
next
Mm.
layer of the network or new developments or new installations. So that's definitely come out as a use case. There are
Mm-hmm.
also other
Mm-hmm.
use cases which are deeper around anomaly detection and kind of being able to detect certain scenarios and alerting users and so on. But one use case that's come out is this incident management, which we are definitely going after.
Interesting. So clearly, as you're talking about getting the feedback, at some point, you, this could be a product. Would you consider this one of your R apps too at some point? Is that the way you view it, or how do you view this?
Yeah, the great question. And I think it's still evolving. How
Mm-hmm.
What is the
Mm-hmm.
format in which RAN GPT will be injected into the RAN is evolving.
Right.
There is clearly an offline pure software module use case where
Mm-hmm.
there is
Mm-hmm.
offline data that you just want to
Right.
analyze, slice and dice, and get different insights out of it. You can
Mm-hmm.
clearly see an offline software module use case for it. There is
Right.
also a streaming data automation use case. As data
Mm-hmm.
is being generated from the RAN, look out for certain things happening. And if certain things
Mm.
happen, do something else. For example, the automated control use case, those would
Right.
become our apps. They have to sit in some kind of a non-real time RIC SMO setting or a SON
Mm-hmm.
setting, and
Mm-hmm.
they'll become equivalents of our apps. That's the vision right now.
Very interesting. I see this going forward as quite interesting. Obviously, you're using certain foundation models right now. Not going to go into details, but I think as time goes on and you guys learn more, I could see some level of improvement, even some pruning or selection of different foundation models out there, such that you could deploy multiple of these in inferencing across the network, even at the edge, and have these things run automated control, right? It's a different way to control of the RAN that's in some sense sort of self-learning, right? Self-adapting, right? And I think that was, I think when I first met you guys at Aira, it's the your goal was, look, ML is really powerful, and if you give it the right data and the right training, the models can replace very sophisticated algorithms that don't always get it right, even with heuristics. ML adapts, right? That's the one thing that I learned from you, if anything. And in this case, the generative AI is a very powerful tool as well in this kind of situation. And I'm hopeful that, and with this early demos and early traction and examples, I'm hopeful that it's another path in the Aira ML toolbox in terms of optimizing the RAN in the network. Very nice demo.
Yeah, thank you, Roy. Like I had mentioned, we are telco experts. We have expertise in the telco domain, so we know how to generate these insights and how to best use the new capabilities that are getting generated from things like large language models and generative AI and apply them to telco. That's our mandate and our vision.
Yeah,
So we are very happy that the reception for RANGPT has been what it is. It's been very positive. And yeah, we are looking for these early adopters who can join us at the table in defining impactful use cases. That's been the mode of these feedback sessions. And there have been, again, very pleasantly encouraged and surprised that the uptake has been there. There is positive engagement from multiple operators saying, yes, let's define something together, let's do something together, this is interesting. Yeah, you'll hear from us more about
yep,
what we are doing in terms of foundational models and how we what's our view on fine tuning it and where does fine tuning play a role. How do you maintain the goodness of foundational models evolving at their own pace while at the same
right.
time adapting that pace of evolution to telco via fine tuning. So we have our own thoughts and our own approaches to that. We'll be sharing some of that in due course, and we'll be also sharing some news about some of the work that we are beginning to do with operators. Stay tuned, is I
Excellent.
guess.
Yeah, I will. I'm absolutely going to be staying tuned on this one for sure. All right, Ravi, thank you. Really appreciate the time and the insights, and hopefully the audience, as you watch this, hopefully you found it useful or found it as interesting as I did. And we'll wait to hear more from Ira and Ravi and the team. All right, thank you, Ravi, and thank you for watching this.
Thanks, Roy. Have a good day, everybody.